Welcome back to lesson 14 in our study of the application layers in the course Network and Distributed Systems, based on the text Computer Networking, a Top-Down Approach by Jim Couros and Keith Ross. We were just talking about sockets in the last lesson, so let's go ahead and pick up where we left off. As we have already discussed, UDP establishes no connection between client and server. There's no handshaking taking place at all. The sender attaches an IP destination address and a port number to each packet, and the receiver takes that data from the packet after receipt. UDP transmitted data may be received out of order or even lost. And from the application point of view, it provides unreliable transfer of packets. Unlike UDP, TCP is a connection-oriented protocol. This means that before the client and the server can start to send data to each other, they first need to handshake and establish a TCP connection. One end of the TCP connection is attached to the client socket and the other end is attached to the server socket. When creating the TCP connection, we associate with it the client socket address, its IP address and port number, and the server socket address. With the TCP connection established, when one side wants to send data to the other side, it just drops the data into the TCP connection via its socket. This is different from UDP, for which the server must attach a destination address to the packet before dropping it into the socket. The client has the job of initiating contact with the server. For the server to be able to react to the client's initial contact, the server has to be ready. This implies two things. First, as in the case of UDP, the TCP server must be running as a process before the client attempts to initiate contact. Second, the server program must have a special packet that welcomes some initial contact from a client process running on an arbitrary host. With the server running, the client process can initiate a TCP connection to the server. This is done in the client program by creating a TCP socket. When the client creates its TCP socket, it specifies the address of the welcoming socket in the server, namely the IP address of the server host and the port number of the socket. After creating its socket, the client initiates a three-way handshake and establishes a TCP connection with the server. The three-way handshake, which takes place within the transport layer, is completely invisible to the client and server programs. During the three-way handshake, the client process signals the special welcoming socket of the server process. When the server receives the request, it creates a new socket that is dedicated to that client. Students who are encountering TCP sockets for the first time sometimes confuse the welcoming socket, which is the initial point of contact for all clients wanting to communicate with the server, and each newly created server-side connection socket that is subsequently created for communicating with the client. From the application's perspective, the client socket and the server's connection socket are directly connected by a pipe. The client process can send arbitrary bytes into the socket, and the TCP guarantees that the server process will receive, through the connection socket, each byte in the order that it's sent. TCP then provides a reliable service between the client and server processes. Also, the client process not only sends bytes into, but also receives bytes from its socket. Similarly, the server process not only receives bytes from, but also sends bytes into its connection socket. Here you see an image depicting the three-way handshake of a TCP socket. This is the real difference between UDP and TCP. UDP does not guarantee reliable service of any kind. UDP simply ships the packet toward the destination and it's done. TCP, on the other hand, guarantees that there is another host listening and establishes a connection with that host. It then monitors the transfer and guarantees that the packets are received correctly. This concludes our discussion of the unit on the application layer of the TCP/IP model. Of course, it probably does not conclude your requirements for this unit that have been assigned by the facilitator. In the next unit, we will begin our study of the transport layer model.